Okay. Okay. I see someone says, I want to choose KitKat, but I don't know how. Okay, so go to the top of your screen and you'll see like a toolbar pop up where it says View Options. And then if you click that, you can annotate. You can click Annotate and then add text or stamps. Okay, so we're good to go. So we're going to get started. I think, Heather, if you're with us, if you want to start, you need to stop sharing your screen. Perfect. Okay, so let's get started. So welcome everybody to session number 1 for the addition and subtraction continuum. We are so excited that you are here with us. We really appreciate you taking your time. We know it's a busy time of year. We also understand that there's lots of other obligations. So again, we really appreciate you being here and kind of digging in a little bit to the early strategies from the addition and subtraction continuum. Awesome. Next slide, please, Heather. Okay, I just want to say a big welcome. So myself, Samantha, and Alicia are kind of co-hosting, but really Heather's doing all the heavy lifting here. So Heather Wark, and we're very, very fortunate to have her share all of her learning with us today. So welcome to Heather. She's currently in the background in Thunder Bay, saving her voice because she's tackling a nasty cold flu bug of some sort. So if she starts coughing at any point, be patient. So, yeah. Okay. Okay, Heather, next slide. Thanks. So today, the strategies we are going to talk about counting 3 times, counting on and counting back. So the counting on piece is for addition. Counting back is when we're talking subtraction. Counting on from the larger number. And we are also going to dig in a little bit to the difference between direct modeling and tracking, which is something that can look a little bit different for students as they're going through the early stages of development. Okay, next slide. Okay, and we just want to remind you about some upcoming sessions. They will also be at 3:45, same format as this. The principals will send out the Zoom links or codes you need. But, oh, there's somebody's mic.
I don't know. Are you okay? I'm just doing this stupid.
Are we good? Okay. So subtraction is Tuesday, November 12th, Tuesday, November 19th, and then multiplication and division Thursday, November 7th, Thursday, November 14th. Okay. All right. So one more kind of question we want to see, just because we want to get a feel for the audience and how comfortable you are with some of these early strategies. If a colleague asked you to explain the counting 3 times strategy, how comfortable would you feel? So we just kind of want to see where you are at. So if you could annotate, if you feel really good about it, you feel like you could run a PD day on it for us, or if you're kind of in the middle, or if you're not sure, just kind of let us know where you are comfort-wise with this. And again, if you don't know how to do that, did you just say that? No, go to the top. Yeah, okay. I kind of zoned out I was reading the chat. So go to the top, view options, click annotate, and you can put any symbol or text or whatever you'd like. And I love that I'm seeing people who are owning the fact that maybe they're not as comfortable with counting 3 times, and that is exactly why we are here. So we are so glad that you are joining us. Our goal for the end of this session is just to kind of build that comfort, because we all are definitely at different spots. So we appreciate your honesty, and again, thank you so much for being here. Yeah, absolutely. Okay. All right. So a pretty good mix. Yeah, this is great. Now, now we know kind of where everyone's coming from. Great. Okay, Heather, I'm going to throw it to you. Thank you for being here, Heather Wark, and it's all yours.
All right. Sorry, I was when there's been annotations, there's always a little bit of a delay while we get those erased. So welcome everyone. I am really excited to be here also, and I'm really grateful that you took the time out to be here with us. I know life is super busy, and so the fact that you're here either now or later on watching the recording means that you really value this information. So we're going to get into it so we don't waste any of that precious time that we just talked about. So the last session or sessions, depending on if you've joined us before or not, we talked about the fact that working with the continuum requires us to rethink how we teach mathematics often, at least from how we probably experienced it as a learner, to think about math as something that develops. With support from teachers, we can help students to develop various strategies, but that students have to be developmentally ready to move on to the next strategy or the next layer of understanding. And so I've shown this image before, talking about just the fact that there are some different strategies and that each one of these strategies for locomotion is just right for this little child who's pictured doing it. And that we wouldn't expect the little child on the left to all of a sudden tomorrow be able to do what we see the little child on the right doing, that there's a whole lot that's going to happen for that child between those 2 points. And a lot of that work actually looks like that picture in the middle, right? There's the parent holding both hands and helping them gain the muscle and the balance that they're going to need in order to be able to do what we've got on the right. And so we're actually kind of looking today at some similar territory in mathematics and talking a little bit about what does it look like for teachers? What is it that they're doing to help students transition from where they're at, maybe, you know, like the little child on the left? What is it that they have to be able to do differently and know differently and understand differently to be able to get in on the stuff that's on the right? So I'm excited today. That's what we're going to tackle a little bit. Okay, here we go. So we're going to take a look at this question. So let's pretend that you have 6 fish crackers and I give you 8 more. Do you know how many fish crackers you would have altogether? So I just want to give everybody, you know, I know some of you are together in groups and some of you are individually or sitting individually, but I just want to give you like 1 minute to think about really early strategies that students might use to solve this problem, just to kind of get our heads in the headspace. All right. And you guys have some smaller children at home too, right? So some of this will be familiar to the types of things that your kids would do. We're certainly in the territory here of kindergarten and first grade, and so that's where we're going to sit with these strategies today. We do still see them later on, and I am going to talk about that a little bit as we go forward. All right, so the first strategy that we're going to take a look at is this one over here on the farthest left-hand side of the continuum, counting 3 times. And you can see that it falls in this phase here, the direct modeling and counting. So we're going to expect to see the child using direct modeling and counting as their executing this strategy. So let's take a look and see what it looks like. So here we go over here. So there's a few different ways that students might solve this problem. And they might take cubes, and they might count out 6 cubes, 1, 2, 3, 4, 5, 6. And then they might count out 8 cubes, 1, 2, 3, 4, 5, 6, 7, 8. And then they might count them from the very beginning again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then say that the answer is 14. So using manipulative like cubes, that's what counting 3 times would look like.
Heather, I have a question for you. This has got me thinking about like the Number Talks book, because we love Number Talks. And I've had a lot of teachers ask me about the difference between counting all in the Number Talks book versus counting 3 times. And is there a difference? So I'm just curious, I guess, what that would be.
Yeah, I don't think that there is a difference between what they mean by their label counting all and what Alex means by her label counting 3 times. I think that they are synonymous as they're written in both books. The reason why I like the counting 3 times label is because I think it's just a little bit more specific about what that strategy actually looks like, because when you're counting 3 times, it means that you're going to say the number 1 3 times. Mm-hmm. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. When they first build the 2 sets, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the child will say the number 1 3 times. We're going to look at our next strategy that we look at. The student is going to count all the cubes.
Okay, awesome.
But they're not going to say 1 3 times. And that's the distinction between the 2 strategies. So for me, the label counting all, there will be other strategies where the child will count all, but not count 3 times.
Mm-hmm. Okay.
But I do think as it's written in the book, that's what she meant.
Yeah.
I think.
Okay.
Yeah.
So can I also ask just quickly one more question? I do remember having a conversation at the PA day with a teacher who was wondering if it was still counting 3 times if the student was still using their fingers. So they were able to subitize and know what a 3 looked like, for example, and then a 5 looked like. And so they were able to put those up and then go back and count it by 1. Is that still counting 3 times?
Yeah, so if they were doing a smaller addition problem than the one that we're looking at, where they can actually build those sets on their hands, so they might put out 3 and put out 5, but they don't actually have to count those because they know what those look like. This can be the same also if they're working inside a 5 frame or a 10 frame, something that they can just subitize the amounts in and they don't have to count. But so they might just put out 3, put out 5, and then if they count from 1, 1, 2, 3, 4, 5, 6, 7, 8, then that would be included as counting 3 times.
Okay.
And I know that it gets a bit tricky because that's a pretty fine nuance that probably only like kindergarten and grade 1 teachers need to know about. But the reason why Alex put them all together on the continuum in one box instead of making, 4 or 5 boxes for all the different variations between counting and subitizing that they could do, combinations, right? They could just subitize one of the sets and then count the second one and then start again from 1. There's a whole bunch of different ways. But the reality is that for teachers, knowing the value of this work is in using the continuum to help teachers know what to do next
Yeah.
with students. And the way Alex was looking at it is that for those students, regardless of whether they're counting out the sets or subitizing the sets, their next maneuver is probably the same. So putting them in the same spot tells the teacher the same information, and it keeps the drawing a little bit more simple than if we had all the different options there. But it's important questions because it is a little different. It's not quite the same, and they don't say 1 3 times.
Right. Okay. Thanks, Heather.
No problem.
Good question, Alicia.
Is there anything else in the checks chat on that one from teachers or?
Nope, not yet.
Okay.
You were pretty clear there. That was great, actually, because I just got some clarified understanding on that as well, about what it looks like when you have a tool versus fingers and that kind of stuff. That was good.
Okay, because they can do it with drawings too, right? They can draw out the sets, which you sometimes see.
Yeah.
So they could draw, we were doing 6. So they could draw 1, 2, 3, 4, 5, 6, or they could draw and then draw out 8, 1, 2, 3, 4, 5, 6, 7, 8, and then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that would also be counting 3 times. All right. So the next box that we have on the continuum, and I think it's important to point out here that, this continuum, we're talking about addition in our sessions, but when you look at the top of the continuum, it says addition and subtraction. And it says addition and subtraction because the strategies that are on here, for the most part, can be used when students are solving what we would typically call an addition problem. And they can also be, many of them can also be used when students are solving a subtraction problem, or all of them. And so in order to keep it simple, Alex has, in some cases, as is with this box, included both the addition and the subtraction one together in the same box. So counting on would be something we would see when students are using addition, whether solving addition problem or using addition in a subtraction context. And counting back, though, would be one that we would only see in a subtraction context when a student is moving backwards, maybe starting with an amount that they have and then subtracting by counting backwards. But sometimes, for teachers who are just new to the continuum, it looks a little confusing to have both of them in the same box. But again, it's because developmentally speaking, they both represent student understanding at a certain point. And so your next move is the same, regardless of whether they're counting on, for addition, or they're counting back for subtraction. I don't know if there are any questions about that.
No, but we're just going to be kind of zeroing in on the addition piece of it today, right?
Yeah, we're not going to look at the subtraction, just to kind of keep it simple and for us to be able to get up and get on to a few more things.
Okay.
But yeah, we're gonna zone in just on the addition one. So today we're going to talk about counting on.
Okay.
So one of the things that you'll notice in the counting on is that I can't remember the box cover goes across the phase line. So half of the box is in blue and half of the box is in orange. And so that's important anytime a strategy goes across the phase lines, because it means that it can look like a little bit different, whether it's on one side or the other. So we're going to start by looking at the counting on when it's on the blue side. So the direct modeling version of counting on first. So when a student is using direct modeling, I'm going to use cubes, but they don't have to. They can sometimes use their fingers depending on the numbers, but they will set out, and I'll show you with my fingers with this problem in a moment, but they're going to count out the first set and put it out if they're using cubes. So here we go. Here's our 6. So 1, 2, 3, 4, 5, 6, and then they'll count out the second set. 1, 2, 3, 4, 5, 6, 7, 8. So there's our second set. And then this time, instead of counting back from the beginning of the first set, they'll know just a little bit more. They'll understand just a little bit more than our previous student who was counting 3 times, and they'll know that they can actually start counting with the number 7 here. So they can say 6, 7, 8, 9, 10, 11, 12, 13, 14. And that is going to be direct modeling and counting. The thing that's one of the important things to note here is that this student knows when to stop counting because they run out of model.
Mm-hmm.
So they didn't keep saying 15, 16, 17 because they ran out of cubes to count. So the model, the direct model, helps them know when to stop.
Mm-hmm. I'm thinking of, is it the game Real Counting On that I'm thinking of that really supports how to get kids to start doing this counting on? Is that the one I'm thinking of?
Yeah.
Yeah.
So
Okay.
there's a game in the book, and you're pulling me off script
Sorry.
here.
Sorry.
No problem, no problem. I should
just kinda
probably
popped into
know
my
the
head.
page number of that one, 163.
Look, see, you
For
were
folks who
super
have the
fast.
book. Yeah, well, I sort of know where they all are, but yeah. That one's one we use a lot because often grade 1 teachers really want to know, how do we move our kids from counting 3 times?
Mm-hmm.
They can get a little bit stuck there, and we're going to talk about that in a minute.
Okay.
And so here's the stuck point right here. So what is it that causes our kids to get stuck in one of the phases? Because that tends to be where the sticking points are, is on those phase lines. And so our kids get stuck in counting 3 times because of this key idea. And I know it's a key idea because it's on the bottom part of the continuum. And a key idea is different from the strategy because the strategies are things that we can actually see. And we can look at it and say, oh, that's counting 3 times because the student counted the first set and counted the second set and then counted from 1 again at the beginning. And the key ideas are something that we infer based on what we see the students doing or not doing. And so it's not something that you necessarily see. But I'm just going to talk for a moment about the key idea of cardinality. We did talk about it in our first multiplication session, but in case you missed that one, we're going to go over it here because it's certainly a very important key idea. So cardinality is usually defined. Now I'm going to try to write and talk at the same time, which never goes well. Okay, cardinality. Multitasking is not something I do. I do one or the other. It's usually defined by this explanation. So when students first learn to count a set, so we were using 6, so I'm going to stay with 6, they will count it correctly. If they're going to count it correctly, they'll give one number word to each object: 1, 2, 3, 4, 5, 6. And then if you ask them after they say 6 here, so how many dots are there? If they say 6, then they understand that that last word that they said when they counted actually represents all the dots and not just that last one.
Mm-hmm.
Where they said 6. when young students, and it's maybe hard for us to imagine, but those folks out there who teach kindergarten and grade 1 will know that if you ask that question to some kindergartens and some grade 1 students, if they count this set 1, 2, 3, 4, 5, 6, and you say, so how many dots are there? Then they will actually go back and count the set again, 1, 2, 3, 4, 5, 6. And if you say, so how many are there? They'll say 1, 2, 3, 4, 5, 6. And if you were to ask them, where are the 6? They might just point to this last dot where they said 6, because they haven't yet constructed the idea that that last number they said actually represents the quantity of the whole set. They're just names of the objects, like Alicia, Sam, Heather, Bob, etc. 1, 2, 3, 4, 5, 6. So just that one right there is 6. And that's why when you like move them around and you say, so how many are there? Like now they're all different. They're all going to have different names this time because you've moved them. So it's not the same.
Alicia's in Bob's spot and Bob's in Sam's spot, and then it's all confusing.
I'm sure it's more complex than that, but certainly yes. For them, it's completely, different when you move them around. Even if you don't add any and take any away, it's just all different. So cardinality is that understanding, and so that's important to us because if they don't know that the number 6, and not just know it, but like really trust and believe it. A lot of teachers talk about this as like a really firm trust that if they don't really know in a deep way that is 6, that whole set, if they're gonna try to add on to that set, how do they really know that the next number they're going to say here is 7?
Right.
And that's what we're running into with counting 3 times and counting on. So we work really hard at trying to build this trust and this cardinality. And as you pointed out, real counting on is one of the games that helps kids develop a deeper trust for that cardinality. Okay, so as I pointed out, counting on is actually on both sides of the orange.
Mm-hmm.
The one that's on the counting more efficiently and tracking side of the orange is the one that most people are more familiar with. And so this one is the counting on, and then as you see at the top, this one says tracking. And if I was going to ask most adults to show me counting on, this is what they would do. We don't typically do the one that I showed you earlier. This is the one that we would typically do. And so the way that it looks is, you start with a number in your head usually, in this case 6. And then you say a number and you use your usually fingers, but doesn't have to be, but usually fingers to help you track how many numbers you've said. So 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to try to put my hands like this now. And I know to stop here. How do I know to stop here? I know to stop here because I know what 8 looks like on my fingers. So in order to be able to do this strategy, kids need to really know how to subitize these amounts on their fingers so that they know when to stop. Otherwise, they can't make use of this strategy, or they have to have some way of knowing how many they've said, how many numbers they've said. Because they are doing 2 things at once. They're both counting up the number sequence, 7, 8, 9, 10, and they're thinking about when they're going to stop. 11, 12, 13, 14. And so they have to actually do two things at once. So it's actually quite a bit more cognitively challenging than the other side of this box. And I think this actually gets us into a little bit of trouble as educators because we see our kids counting 3 times, and we know how we would count on. And until Alex put this continuum together, I wasn't at all aware of that other type of counting on. And so we would be trying to get our kids to jump all the way over that direct modeling version of counting on and right to tracking, which is really a lot harder. Are there any questions that come up in the text chat about that?
Not yet, but I was just thinking, like, you were kind of saying that they really need to explore that direct modeling piece to build the ability to go to that tracking. Like,
yeah, some kids, like, that's the thing. Some kids, it's so fast through that transition, you don't even notice it, or it happens so early that they were already through that before they even hit grade 1. But other kids, they're just going to need some more time. So just knowing, that's the interesting thing about a developmental continuum, is how long each kid stops at the different stops along the way does vary, and how much work they're going to need on constructing those key ideas to move on to the next piece. That varies too, and it depends on what their experiences are outside of school, which of course we can't control. All we can control is what they experience inside of school. And so just knowing that it is going to vary from kid to kid, and the things that we can do to help them.
But that really connects to that knowing your learner piece.
Yeah.
I feel like Pam would be happy at me right now saying that, because that's it's such a true thing, right? Like, there's that whole piece of what they're doing in school, out of school, how that connects to their understanding, and how long it may take them to grasp something, and how much direct modeling they may need to grasp something.
And I think too, that's a nice connection to, I know at our last PA day, we talked a little bit about the similarities and differences between the DRA system that we have been using and also this continuum. And the same goes mathematically as it does for reading. Students are going to progress based on where they are developmentally. And I think that we really need to give ourselves permission to be okay that students aren't going to progress at the same, and we really need to reach them and meet them where they're at to help build that solid foundation that we know they need.
Yeah, it's such an exciting time, I think, to be a math teacher, because, we're really, I feel like for some time, maybe the first time, really understanding and digging into the research is there with us on how kids actually learn math, not just, how math develops itself in its own how it develops, but actually how kids and all learners develop mathematically. And so it's an exciting time to be a teacher in math, I think.
Oh, we're excited, Heather.
Well, everyone who's here is obviously excited. All 38 of us.
No, there's more. People are sitting together.
Oh yeah, that's right. No, it's awesome. I mean, that's awesome. I'm astounded. If it's more than just myself and like my math geeky friends, I'm like pretty excited. Okay, so we're going to move. I just wanted to clarify maybe one last time about the difference between counting on using a direct model versus counting on with tracking. And so with the direct model, there will be something put out first that the student will count. So we were doing 6 plus 8, so they have to put the 8 out somehow before they start counting on. That's really the key. So either they'll put out 8 cubes, or they'll put out 8 fingers, or they'll put out 8 dots, or something like that. And that's going to allow them to count on without having to worry about when they're going to stop, because they're going to run out of objects. If they're not putting the 8 out first, then they are probably tracking somehow. And so if you have some video or whatever and you're not sure about it, which one it is it counting on a direct model, is it counting on tracking? I'd love to see, you know, some video of kids that maybe it's a little ambiguous, because one of the things I like to say about the continuum is I mean, I love the continuum, but kids don't always color inside the lines. So
No.
we've created those boxes to help us as educators, but sometimes they don't stay in the lines. So they do really interesting and unique things that sometimes are not completely inside one box or the other.
Yeah, so
I just put
guess,
this. Yeah,
sorry,
go
I
ahead.
was just gonna say, if anyone does have any cool videos or questions like that, like feel free to share them with like your building's coach, and we can share them with Heather too if you really do want to see if you can trick Heather and see if she can figure out what the student's doing. It'd be interesting to see.
That'd be super fun for me.
Yeah,
Those are the kinds of things I do on a Saturday night for fun. Okay, I wish I was joking, but I'm not. Anyway, yeah, so I put this red line in here because that phase line, it really is a distinguishing line on that cardinality key idea. Do they really trust their understanding of those, usually in the beginning, small numbers enough to be able to count on from that spot? The other one that we get asked a lot, and this is the last one we're going to talk about in this session, is counting on from the larger number. And so you probably all know what this one's going to look like, but hey, we're going to model it. This one's in the orange, so this is going to be a counting on and tracking strategy. So this is what it would look like. Okay, so if they're going to do, the question that we asked had the number 6 in the first position in the problem. I should probably just, no, I was going to go back to that slide, but it's a little more cumbersome than I'm willing to go through at the moment. So we had,
do you want me to read it, Heather?
yeah, what did we have? What did we?
Let's pretend that you have 6 fish crackers.
Oh, fish crackers. I was trying to remember what we had.
Yeah, I give you 8 more.
Yeah, so we had 6 fish crackers and I gave you 8 more, right?
Yeah.
I'm just going to shorthand the problem. And we picked that order purposefully because if we had, oh, I just noticed that my computer is thinking about running out of batteries, which would not be good. Oh yeah, look at, because I didn't actually plug the plug in. Sorry, friends.
Oh yeah, please do that, because I'm not sure
Yeah.
Alicia and I can deliver the content the same way.
I knew I plugged it in, but I guess I missed one of the plugs. You know, you actually have to attach it to the wall, basically.
Yes.
Yeah, I've heard that helps. Anyway, okay, back to the fish cracker problem. We purposefully put the 6 first so that we could see if children would switch them around. And in this particular case, it doesn't make that much difference, you know, whether you count on from 6 or you count on from 8. They're both similar size, but certainly with some numbers, it would be considerably more, some number combinations, it would be considerably more efficient to start with the bigger number. For example, if you only had 3 fish crackers in the beginning, you know, starting with the 8 would be a lot less work. So you have 6 fish crackers and I give you 8 more. So for this particular problem, counting on from the larger number would be, instead of starting with 6 like we did before, you would start with 8 and you would say 8, 9, 10, 11, 12, 13, 14, and you would just count on the 6. So that would be counting on from a larger number, and it's tracking because I didn't put the 6 out first and then know when to stop. I was building that up as I went, and I had to think about how many have I put out so far, how many have I counted so far, at the same time as I was counting the number sequence. So that's
a lot of cognitive load for a kid to hang on to.
Yeah.
Like that piece of not of trusting that that's the 6.
Trust, yeah, they do. It's a big gap between counting 3 times and this kind of counting on.
Yeah.
You know, that other counting on where they're using the direct model, they can sit there for a little while and have to have a lot of experiences there. Anyway, this one where they know that they can start with the larger number and it doesn't matter the order. It's not going to change the total whether they start with the 8 or they start with the 6. What under that is a different idea on the continuum, and that key idea is the commutative property. And you see that one coming in down here. And so the commutative property, lots of people, you said when we were meeting before today that people were asking you, how do you help students learn to count on from the larger number? It can be a bit of a struggle sometimes for us as primary teachers when they're adding something like 3 plus 8 and they have to start with the 3 because it comes first, and then they have to count on the 8. And we think, tell them that you can start with the bigger number, but they don't necessarily really truly believe it without some experiences in school. So one of the things that you could do in the classroom to help students learn, truly trust and believe that you can count from either one of the numbers, they'll get to the same total. So lots of people ask that question. Oh yeah, right. I forgot we put a slide in that actually said. Perfect.
You're on the ball.
That's it. This is where we wanted you to bring a copy of Alex's What to Look For book. If you turn to page 32, you will find a page that looks like this at the top. And in the book, you go to the ebook, you can see a video of a child using that counting on from strategy by clicking on that image at the top. And so the book looks, the top of the page looks like this, and this is where you can read about the strategy and the key. So we've got cardinality, of course, because it's counting on, like we said, commutative property, which is the idea that you can add those 2 numbers in either order and still get to the same amount. And the bottom of the page, though, I wanted to draw your attention to this part, because this is some of the teachers are really looking for, I think. So this part that's in the classroom and next steps can take one of 2 forms. Sometimes Alex talks about that you could do to help move a student who is doing strategy on this page forward. And sometimes, like in this case, when she strategy that teachers are often trying to figure out how to help students get in on, she talks about what they did in her research school classroom in order to help children understand this. So at the very bottom of this page down here, she talks a little bit about what they did in the classroom. So they looked at all the pairs that made 10, and they realized that if 1 and 9 made 10, the students figured out that 9 and 1 would also make 10, and same with 8 and 2, and 2 and 8, 3 and 7, 7 and 3, 4 and 6, and 6 and 4, and that generated a lot of conversation about, did it matter what order you added the numbers? And they had a lot of conversations at the carpet about that. They also would have done some number talks in the classroom, and I know you guys do. Oh, sorry, I'm jumping ahead of myself. There are also some games that they would have done from the book. So here's the games chart that helps to build counting on. And that idea of cardinality. So here's that real counting on that you mentioned earlier.
Oh yeah, okay.
And they would also have done, in terms of the commutative property, they would have also done some intentionally selected sequences of questions that would bring out a discussion if it's okay to switch the order of the numbers when you add. So I just made this one up, but you could ask in a number talk 6 plus 2, and then ask 2 plus 6. And then when they both get to 8 here, and then you could ask 8 plus 3 and 3 plus 8, and they would both get to 11. And then you could have a conversation about if they noticed anything about those problems, and generate some discussion about the order. And if I was going to run a discussion like this with grade 1s, I would certainly want to have some manipulatives handy so that they could prove to each other why this might always work. Because some of them, they may or may not be in total agreement. And I think that gets us to the end of our scheduled program.
Yeah.
So thank you so much, Heather. I know we just gave you a lot of information, and by we, I mean Heather gave us lots of information. And if you do have questions or you want to learn more, please be sure, ask a colleague, connect with one of the coaches who's in your school. Also, please use the blog lklmpro.blogspot.ca. It has videos and it has activities and next steps. Find a copy of the What to Look For book in your school. And also, please remember there are other sessions coming up. So please do not hesitate to join in on one of those.
And just a reminder of the upcoming sessions. So we do actually have one this week on Thursday. It'll be with, I think, Sally and Kate around multiplication and division. And then a couple other dates on there as well. There'll be some addition and subtraction, and Tuesday, November 12th, Tuesday, November 19th, and then the last multiplication and division Tuesday or Thursday, November 14th. So we would love to see you at those as well.
Okay, and last but not least, Heather, if you can just flip that slide. We always love your feedback. So I have attached just a QR code that will give you a chance to kind of connect to a Padlet. That we would love to hear what you liked, what maybe we could do next time. Just that honest feedback that we really appreciate. We are here for you guys and we want to make this work for you. So if you have a chance, we would really appreciate you connecting in that way.
That's great.
And I'd love to say thank you to folks for coming out. And if you have any questions, please don't hesitate to put them in the chat or give them to us somehow so that we can try to answer them in a subsequent session.
Yep.
Or, we'll stick around for a few minutes if people have some specific questions they want to ask tonight, and because, you might not be able to sleep very well if you don't get it answered.
So that's it. We're done. Thank you for joining us. And again, we appreciate your time because I know it's a busy time of year. So thank you very much.
And thank you, Heather, for everything again.
Yeah.
No
Enjoy
problem.
your evening and the Halloween candy.